So I'm André Bottaro, and I have broken the microphone. I've already presented the vision of Open the Box project with partners last year. It was in February last year, and today I will show you the results of this French collaborative project that has been finalized at the end of the year. And today, Open the Box is still living because some companies like like ours, Orange, is continuing on this open platform that is partly open source and partly freeware. And tomorrow you will have a tutorial with the team here. We have almost all the team people that are named here in the room, except Jacques Pulou. And tomorrow we'll have tutorials to realize the first application on the Open the Box platform with standard OSGI framework and bundles, and several bricks that simplify the management and the application development for partners. There is another part in the tutorials showing how to integrate technology like Zigbee or other technologies, as with the methodology that we named base drivers, and we will see in the presentation how it could be integrated in a full abstraction layer. And talking about abstraction, I was very glad to have Kai Kreutzer before me as a presenter, because he had a great introduction about the home, about all the connections with the cloud that are made now by every provider of a connected thing in the home. And today we need more a brain in the smart home that is not just a connection to the cloud. We would like to have a brain and a platform to develop applications on a uniform and a unique infrastructure. So Open the Box is all about that. And now that Kai has made a brilliant introduction, I will get into technical stuff directly in the results of the Open the Box project. So Kai has made already the lines there. So this presentation here will introduce the customer journey with an open smart home system, and I will give you some snapshots of real demonstration that is running in our labs in Mélan, near Grenoble. And the second hint I would like to make today is to show what is the device abstraction layer that is needed on such a platform, and how what is our contribution here. So about the results of Open the Box project. So in this in the past 3 years, I was leading this project with 4 partners. And the vision was about sharing an infrastructure with several actors, and there are 2 enablers and 2 enabling technology into this that are shared by the partners. So it is one embedded environment in a home gateway or in an over-the-top box, and a smart home management platform that is in the cloud. And all the other actors are providing either sensors, screens that are shared in the Internet of Things, and also other partners are managing an application store that connects the smart home management platform, or connecting mobile applications to it, or connecting a business service platform, making their own cloud applications and connected to the system. So we have a role model that is flexible and that represent all the business models that we could have in the smart home today, with roles of actors sharing this platform. We had also several demonstrations showing how to open APIs to partners. We have in the vision cloud APIs, also APIs in the embedded gateway in a programming language for partners to develop embedded applications. And then, of course, there are also open protocols here for IP protocols and non-IP protocols to connect any device to this infrastructure. So we show that in the demonstration. The thing also we show in the demonstration is that we could simplify the customer journey, the full customer journey from selecting an application on the application store and downloading it in the box and configuring the device access rights to the applications, and we will show that in some snapshots in this presentation. Then we have in this, the project was a research project, so we have addressed several technical challenges with answers to that. So we have a document that is available, but it is not on the website yet, on all the security attacks that could be addressed at the hardware level, at the OS level, and especially at the JVM and OSGI level. And so GTI Tech has especially a proprietary testing platform for that. On hardware resource management, we tackled this issue, and now we have, with the good industrial assumptions as hypothesis, we have answers to how to manage resources and to share resources, have resource quotas per application, per partner on an OSGI gateway, an OSGI platform. And we standardized a part of that in the OSGI Alliance, and we have a reference implementation for that, and we have several papers on that. We have also tackled a special issue in Java that is called the stale reference issue, and we have also made assumptions on the issue that is really the one that we want to address in the smart home with applications maintained by different partners. And here we have also some papers and open source reference implementation to tackle this issue. On the conflict management and application collaboration, this is the laboratory of Grenoble with Adel team that has part of the answers on this issue. And then we had also, especially with IS2T, shown that this environment, this OSGI environment that is called a little heavy by some technical guys. Sometimes we showed that this environment could be embedded in very low end platform with 200 megahertz and 500K of RAM, and IS2T have shown that. Of course, this is not completely standard. We have just a subset of OSGI standard in it, but it works. We have also targeted another platform that is fully comfortable for any developer on Java 8 on Raspberry Pi, so it runs with all the open-the-box stuff. And we have also a third target, which is a trade-off between those two extreme situations with the minimum standard Java profile for OSGI. So I think, that's all for the big picture. And we can continue with more specific items. So just to finish with the collaborative project, and then afterwards I will show what is the contribution of Orange and what we continue today. So on the demonstration we have several base drivers that represent the devices that are available in the home as service, as objects in Java and OSGI technology. For instance, Deltador has made its own base driver with this technology to show that he understands it, and that is a nice methodology. And then above that, above those APIs that are provided by the operator of the smart home environment, we could have several applications given by distinct partners, and we showed that with several French partners. And we'll see also in the picture afterwards that we have contributed as Orange with an application store, and you will see that in the slides, a device management platform, and the device management platform has managed the smart home environment like with the same protocols as it manages 10 millions of home gateways, the Orange Livebox in France today. And we have also a dashboard for the user to configure in a uniform manner any device, any application in the home. And of course, every application has its own dashboard. And here we see the TDOM application, management application by Deltador. Sorry. So let's start with the customer journey. So we have this full demonstration, and I'm sorry we haven't bring it there because we were in Rennes all the weekend for a hackathon with our platform, so we are not able to install the thing here today. So here we see an application store, so it is something that is online today just for R&D purposes. This is not a commercial site with an Orange application store with some applications, and you can download the one from STM Microelectronics, the one from Deltador, and some testing applications from Orange. And here what we see as simplifying the customer journey for the user is that he only sees the applications that are compatible with his devices in the home. And how we do that? We do that because we force the third-party players to declare all the device types that are required for their applications. And they are forced to do that because if they do not require the device types they want to use, they have no access rights at all in the home. So they do that. So that's the first hint to simplify the customer journey. The second hint is that thanks to this declaration of access rights, so here we could of course improve the snapshot and the readability for the user. He sees, like on a smartphone, when he selects an application, all the access rights towards devices that are needed for this application. So here he could validate the access rights that are required. We are thinking about a version where he can choose the devices, the real devices that he would use, and we will see that in the dashboard that is already possible. Then on the user dashboard, we see like on a smartphone, we see applications that are available, and we have downloaded 4 applications here. And we see also all the connected devices that are available in the home. So here we see 4 Zigbee devices, 6 U-Lights and bridges, and 2 X3D devices. So you see here we have a unique dashboard for all the applications and devices that are in the home. Then to manage access rights, we see here that the fire detection application has permissions on some U-Lights and some Zigbee devices. And then if we want to manage the permissions, then the user sees that he could also give access rights to other devices for this application. And we see here that we don't see all the devices that are in the home. We don't see blinds, we don't see some things. We see only the things or the devices that are compatible, that are required, the types that are required by the fire application. So that's a third simple hint, and no big research here, to simplify the customer journey in the smart home. Okay, in the second part of this presentation, I would like to focus on the device abstraction layer. To be honest, in Open the Box, we didn't want to go into this into the abstraction topic, because of course anyone has an idea of it, and anyone beginning on this abstraction layer is making its own abstraction. So we didn't get into this complex issue, but we are able to integrate any abstraction into this the big picture that I will provide you today. So to me, And yeah, in the Open the Box project, we had this this slide for at least 2 years, Sebastian, maybe 3, and we already presented that to HCM2M and Home Gateway Initiative. So there are 3 levels to represent the activity or the devices in the home. We have at the bottom level the technology-specific device representation layer, and in this communication type, we have the developer has to program, for example, the order of sending the command Zigbee specific command with a specific type to an endpoint, and he has to know what is the an endpoint in Zigbee abstraction with a specific Zigbee ID. At another, and we need that we need such drivers at the bottom of the infrastructure. And the second layer, we need this the full abstraction with that I think Kai also mentioned in Eclipse Smart Home viewpoint, with an abstraction that enables the developer to say switched off the radiator with this general ID, and he doesn't have to know what is Zigbee and what is the Zigbee identifier, what is a Zigbee endpoint. And above that, we have applications, and we could have embedded applications there that could have also some APIs above that, business level application APIs, to have the developer or a partner say, then here I need to decrease the overall energy consumption with 500 kilowatts. So that's a high-level order that we can send to the house or to a specific application that handle energy management. So with those 3 types of layers, we understand what that there are several layers for the abstraction, and that is true in the home, in the local box, and that is true also, of course, at the cloud level. So that's why we have also 3 arrows going up towards the device management platform or the cloud platforms. When I now map this big picture into a concrete system about above OSGI, so that's we have a part of that in Open the Box. We have the part that is below. We have also a part that is not here with an application model and a packaging, the device access rights management, the overall device management. So we have also things that are not represented here. But for the device abstraction, we have this part, and we decided just to stop here. So here, what was very important for us in Orange is that our environment has not strong requirements onto the Linux system that is above that, below that. So here we want that this fully flexible, open environment could be deployed in an over-the-top gateway, in a Raspberry Pi, or in a full triple play box without requiring much on the Linux OS. And with this requirement, we have shown in to marketing people and to product owners in Orange that we could install that without requiring any updates of the Linux OS that was in Livebox Play. So here we just need the legacy de facto standard serial drivers that are always in Linux systems in every home gateway in the world, or at least 99% of them. And then all the messages coming from the serial drivers are treated by those base drivers. And here we have a layer of base drivers that is only making the first step for the abstraction. So we have a base driver for every technology that enables to mirror the availability of devices like the services available in the service registry, and we have some details about that in the next slides. And then above that, we could integrate any abstraction with a certain service API. So the abstraction of the Home Gateway Initiative, the one of the OSGI Alliance, the one of HCM2M, the one of Eclipse Smart Home, the one of we could have many today. Maybe Alljoin will have one day, and so on. We could have that at this level, and then we just need adapters between this low-level representation layer and the abstraction that is needed by a partner or by other applications. So we call that refining drivers. It is only a layer of adapters. And above that, then we could have applications. We will be also glad this year to integrate a rule engine like the one in Eclipse Smart Home. So that's why maybe we will have make efforts together with Eclipse Smart Home to have this layer and then a rule engine, Eclipse Smart Home rule engine above that. And then, for applications, there are reactive applications that will be glad to use directly a rule engine, and there are some applications that don't need a rule engine at all, and that just need to present web pages, for example, to show the consumption of the meter. Or there are plenty of examples that show that we need applications without rule engines for a large part of it. And then above that, the link with the cloud, we see that with bridges. So we have a bridge with TR69, and this client is open source. There are links on the website and in this presentation. And this year, I think, we'll also integrate, Eclipse OM2M, so another Eclipse project that is really great. And we made a proof of concept visible at a NetCM2M workshop last year. To talk with a platform in the cloud and opening cloud APIs with HCM2M standards. So I think this is okay with the big picture. And then, so tomorrow in the tutorials and with the team, you will see that we have several base drivers. And what is a base driver? Just an OSGI bundle that is related to one technology, and for this technology it could be UPnP, ZigBee, and Ocean, or others. This brick listens to any event on the specific network of this technology, and then for every device event, it mirrors this event into an OSGI event. So when there is a device that appears in the network, then a special device service registered in the service registry, and then the OSGI platform sends the event. And we can then have the client, the application client could have then calls to methods of this proxy towards the devices. So that's very simple, and that was made already available as a standard for UPnP in 2005, and now we have brought little improvements on the methodology, and we have standardized the one for ZigBee at the OSGI Alliance, and the one for Ocean also at the OSGI Alliance. NTT has made the one for USB, and we can have a lot of efforts at this level to standardize all the base drivers that are needed today in the smart home. Okay. Just an example of the UML schema for the Ocean base driver that we have standardized at the OSGI Alliance. I have no time to go into the details, but that is available here, and you can browse the web to get the open specification. Then for a refining driver, so the refining driver is just an adapter, so listening to events coming from the services that are here, OSGI events saying that there is a device service that is available of a certain type, for example, an Ocean device with the right Ocean switch equipment EEP equipment profile, and then responding to this event, it registers the right adapter in the interface expected by the application, and then you can have several refining drivers for all the abstract types that are needed by your application clients, several partners. Okay, and then just to conclude, so the results of open box seen with these aspects of device abstraction layer, are that ones. So we have an Orange Ocean base driver that is open source We have also the TR69 device management client that is open source for some years now. We have for some Fab Labs, I think Didier, you are interested. We have invented a very simple protocol, Simple B, that could be improved by any developer or maker in a Fab Lab. And then we have the client on a gateway in Java, and we have a client also in C, C++ on Arduino. And just in Run, 2 days ago, some developers make their very early prototype in 3 days with this type of technology, with something on one side and one thing on the other. This is also open source. All the other parts that you will see in the tutorials today, tomorrow are in a freeware license, so you can use that. You have all the binaries, but we do not have open sourced all the things yet for different reasons. And in the future work, I already said that we will integrate, I think, Eclipse Smart Home to have rule engine and abstraction, and Eclipse OM2M to have the cloud APIs that are missing in our end-to-end infrastructure today. Okay, in the standardization level, I've already talked about what we standardized with NTT, Deutsche Telekom, and other operators and technology providers at the OSGI Alliance. What is remaining today is to have this all these concepts in an abstraction that is adopted by a large ecosystem, and we call that an ontology. And we are I think in the few years to come we will populate an ontology with a lot of partners. And this ontology, if this is adopted by a large ecosystem, then we could apply that to any technology. It could be all join, it could be UPnP, it could be OSGI, Linux, or any technology. Okay, of course there are research perspectives, and the ones that are interested in our team are how to handle and detect the conflicts between applications sharing devices. So that's something we addressed partially with the League and the ADEL team last year, and we have to continue. We also have to integrate the big data, the data mining issues, or the data mining enablers into our system. And here we in this mutualized infrastructure, the data platform was not here in the picture in the OpenBox project, and today it enters the big picture with some issues. And last but not least, we have also to manage the IoT infrastructure with a more seamless integration between the cloud and between the box. And we are in this fog computing trend with some researchers on this issue with us. That's all for me. At the end, you will see many slides talking about the standardization deliverables that we got at the end of the open source collaborative projects, the open source results of several partners, and all the publications and PhD theses that were made during this project. Thank you very much.
Any question? No question? Okay.
Very interested in how to abstract. Sorry. Okay. Thank you. My name is Masahiro Nakamura from Kobe University, Japan. I'm very interested in your way to abstract the things to the in order to avoid the very technical specific parts to the dynamic. Do you have any kind of criteria how to determine the level of abstraction of each device? For example, there are many ways to abstract the things. For example, TV. So TV has you just have one abstract TV, or you have a more how to say detailed abstraction like connected TV or legacy TV. So there are many kinds of different levels. So do you have any kind of criteria by which you determine the level of abstraction? It could be very
maybe that is a tough question. What we do and what is really simple as an operator is to map every technology specification with its abstraction model into programming language objects and components. So what we do is that when we have a model, then we model that in the straightforward way into a Java model, and then we give that this service-oriented methodology to integrate those APIs onto the system, and I think that's all we made. So if there is more levels of abstraction, I see at least two, the one for the technology that is below that, and the one for a TV. So if I want to see a TV, I would get there and require a TV with some types, and we can of course register the TV as a service with a lot of properties that can be filtered by the application to get the right TV. Now you can, I'm sure you can have several abstract service interfaces for a TV, and then today I'm not maybe I don't have all the answers, and I just try. I will just try, like other labs, like other standardization organizations, to have to divide the issue into and have several to divide the functions into very simple functions, and then to map that as interfaces, and then a TV becomes to be a set of functions here, and you can get at least an answer to your question, but I'm not maybe the full expert on that.
Okay, thank you very much.
Okay, thank you very much for your questions and your attention.